Have you ever stopped to think about how we build an AI that's genuinely helpful, but without, the risk of it becoming dangerous? Well, today we're diving into a really landmark paper from Anthropic that tackles that exact question. They came up with a pretty radical new way to teach a machine a moral compass.
Okay, so let's get right into it. The real challenge of AI safety isn't just about making AI smarter, right? It's about making it wiser. I mean, how do you actually program principles, ethics, and just basic harmlessness into a system that learns from these massive, unfiltered piles of data? This is honestly one of the biggest questions in the entire field.
And this leads us to the core dilemma. See, early on, researchers found themselves in a real bind. If you trained an AI to be as helpful as possible, it might happily give you instructions for all sorts of dangerous stuff. But if you went the other way and trained it to be completely harmless, it would just refuse to answer anything remotely sensitive, which made it frustratingly useless.
This tension created what the paper calls the helpfulness versus harmlessness problem. It was this trade-off that, for a long time, seemed totally unavoidable.
And this is the perfect illustration of that exact trade-off. On one side, you've got a helpful AI that will tell you exactly how to commit a crime. Obviously not good. On the other side, you have a harmless AI that just completely shuts down when it's faced with a tough question. Also, not very useful. So the big question was, how do you get the best of both worlds?
Anthropic's answer was both elegant and incredibly powerful. What if, and this is the key insight, instead of trying to micromanage the AI with millions of human labels for every possible bad thing, what if you could just give it a conscience of its own?
And that's what they called constitutional AI, or CAI. The idea is simple, but honestly, it's brilliant. You give the AI a short, explicit list of principles, its constitution. Then you teach the AI how to use that constitution to critique and improve its own behavior. It literally learns to supervise itself.
The whole process happens in two main phases. So let's start with phase one, which is all about self-critique. The first phase here is built on this really powerful idea, supervised learning for self-correction, right? Before the AI can actually improve itself, it first has to learn how to spot and fix its own mistakes. Let's break down how that works.
So here's the play-by-play. First, a model that's just trained to be helpful gives a potentially harmful answer. Then, it's prompted to critique that very same answer based on a principle from its constitution. After that, it revises its own answer based on its own critique. And finally, a new, improved model is fine-tuned on thousands of these self-corrected examples. It's basically learning from its own guided introspection. It's pretty cool.
And this just brilliantly shows the process in action. This is a real example from the paper. The AI recognizes that its own advice on hacking is harmful because it's illegal and an invasion of privacy. That's the conscience at work, using that constitution to identify its own missteps.
But the training doesn't stop there. So let's move on to phase two and see how this all builds into real self-improvement using reinforcement learning.
Okay, so in this phase, the AI generates two different responses to a prompt. Then, using its constitution, it has to decide which of the two is better. Less harmful, more ethical. This creates this huge dataset of AI preferences. And that data is used to train what's called a preference model. You can think of it as the AI's internal compass for what a good answer looks like. That compass then becomes an automated judge. Finally, the AI is trained to generate responses that get a high score from this AI judge. This whole process is called reinforcement learning from AI feedback, or RLAIF.
So the big question is, did it work? Did this whole complicated process of self-critique and self-improvement actually solve that helpfulness versus harmlessness problem? Well, the results were pretty groundbreaking.
This chart tells the whole story. Think of it like a game, where the goal is to get a high score in two categories at once: helpfulness along the bottom and harmlessness up the side. The best spot to be is up and to the right. Now, notice the older methods, those blue and orange lines. They force a trade-off. As they get more helpful, they become less harmless. But look at that gray line. That's our constitutional AI. It just moves steadily up and to the right, getting better at both helpfulness and harmlessness at the same time. It completely broke the trade-off.
So let's see what that actually looks like in practice. When you asked a really sensitive and complex question, the previous generation of harmless models would just shut down. Sorry, can't respond. It was safe, sure, but also completely unhelpful and really evasive.
But the constitutional AI model? It engages with the question thoughtfully. It acknowledges how serious the problem is and gives a nuanced, factual, and harmless response that explains the complex factors involved. This is it. This is that non-evasive, helpful, and harmless assistant that researchers had been aiming for.
So, you can see this paper wasn't just some academic exercise. Its impact has fundamentally shaped the entire field of AI safety and the design of the AI assistants we're all using today.
So, what are the big takeaways here? Constitutional AI proved that an AI can supervise itself to be safer. This was huge because it drastically reduced the need for those costly, slow, and really hard to scale human label datasets. That was a major bottleneck. The result is an AI that's way less evasive, it's more transparent, and it can be steered by a set of explicit, understandable principles.
And this research leaves us with a pretty profound final question. The ability to give an AI a set of principles, that's an incredibly powerful tool. And it forces us to ask, if we can encode values into a machine's conscience, who gets to decide what those values are? That's a conversation that really involves all of us.
This is for entertainment purposes only.